are here with Ed, one of our senior engineers. Ed, did you want to go ahead and introduce yourself?
Hi, I'm Ed Kankosian. I'm a professional engineer working for BMC Group, specifically the IBC Certifications Group.
And Ed works closely with shake table testing. Ed, can you tell us what exactly shake table testing is?
Yes, shake table testing is a earthquake simulation used to qualify mechanical electrical equipment that's going to be used in buildings.
And why is shake table testing preferable to analytical methods?
Shake table testing is an actual physical test as opposed to analytical methods, which are calculation or software-based simulations. Over time, the physical testing done by the shake test has proven to be more rigorous, more accurate, and a better simulation of an actual earthquake.
And what are some of the limitations of shake testing?
Shake table testing has to be done in a manner in which it simulates the earthquake appropriately at an appropriate level for the location in which the equipment is going to be installed. You have to design the adapter between the equipment and the shake tables, which we refer to as a fixture. It has to be designed appropriately so that it doesn't amplify or excessively reduce the actual forces going in the equipment. You want whatever the earthquake is whatever you're designing for the earthquake to withstand to be the actual forces going into the equipment.
And Ed, can you tell us what is confidence analysis and how does it relate to shake testing?
We do confidence analysis here at the BMC Group, and what it is an analytical evaluation of the equipment that's going to be tested before you ever put it on the shake table. You do this to identify the weak areas of the equipment because a shake table test is a potentially destructive test. And when you do a confidence analysis ahead of time, you reduce the destructive potential and you stack the odds in favor of passing the shake test.
And how important is fixture design in relation to shake table testing?
The fixture is an adapter between the equipment and the shake table. And you want to design the fixture so that it is very rigid, more rigid than the equipment. And you have to do this such that you don't cause fixtures that are improperly designed, they're too flexible, will actually amplify the forces in the equipment to a point where you get a false failure of the equipment potentially.
And how does accelerometer, gosh, I messed that word up, didn't I?
That's correct.
Oh, it is? Okay. And how does accelerometer location impact the shake table testing?
During the shake test, accelerometers are mounted in different locations on the equipment being tested. This is to measure the response of the equipment to the actual earthquake simulation of the shake table. You're trying to measure and control global responses of the equipment. You want to make sure that accelerometers are placed in locations that are appropriately measuring global responses and not localized responses. Localized responses can give you inaccurate measurements, inaccurate control of the shake table, and potentially cause a failure where failure wouldn't normally occur during the test.
And what sets BMC Group apart from many of its competitors?
The BMC Group offers its certification services in a turnkey fashion. We evaluate the equipment, we do confidence analysis to identify the weak areas of the equipment, we work with the manufacturer to strengthen the equipment, we design the fixture which adapts the equipment to the shake table, we review the report, we do it all.
Awesome, Ed. Thank you so much for being here with us today.
You're very welcome.